everybody. Let's look at question 2. Here we have two lines that intersect at a point. We're asked to find the gradient of one of them. We're asked to find the point of intersection, and then we're also asked to find the equation of a line based on some of that previous information. Okay, so let's start with question 1. It gives us the equation of a line L1. It tells us y is equal to ax plus 5, but it doesn't give us a. They are asking us to solve it. So we need to solve this a. It says find the value of a. So what is a to begin with? Well, we know that our slope-intercept form is y equals mx plus b, and m itself is the slope. So they're asking us to find the slope. A few different ways we can do this. I mean, putting points into the calculator, running a linear regression is possible, but it might not be the most efficient. I think the most efficient way is probably going to be creating triangles. So choose just any kind of like random point on the line. Make sure it crosses at some point, the crosshairs, this point of intersection. Label them, create a triangle, and then let's find the slope, the rate of change, the change in y over change in x. So here we've got 1 point. X is equal to 2, and y is equal to 4. And let's just choose another point down here. This one will do. X is equal to 6, and y is equal to 2. And we're asking ourselves the question, well, what is the rate of change? What is our change in y? So we started at 4 and we go down to 2. Our change in y is, well, we've gone down -2. And what is our change in x? Well, we started at 2 and we're going to 6. Our change in x is 4. Now they look the same, but the scale is different. If you see on the y-axis we go up by 1, on the x-axis we go by 2. So don't let that, I guess, confuse you. So what is m? M is the slope. That is change in y over change in x. In this case, our change in y is we've gone down by -2. And our change in x, well, we've gone across 4. Simplifying a little, -2 over 4 is equal to -1/2. So, well, why is this m? Well, we conventionally call slope m, but here they're calling it a, so I guess just to be consistent, we can say a is equal to a -1/2. So that means for each x, we move down -1/2 unit in the y direction. I guess that's what we could say. So a is equal to -1/2. Alright, and we know our equation of a line. We're going to need this actually, so let's write it out. L1, what is that? That is equal to, y is equal to, and we just said it's -1/2 x plus 5. And L2, they gave us that, and that is y is equal to -2x. -2x plus 3. Okay, so let's go on to question B. Find the coordinates of R. R is this point right here, and it's the point where they meet. So what do we want to find out? We want to find out when L1 is equal to L2, or I guess maybe more familiar. This is y1, this is y2. We want to know when y1 is equal to y2. So I guess if we know that y1 is equal to -1/2 x plus 5, and we know the value of y2, we just set them equal to one another. 1/2 x plus 5 equals -2x plus 3. And now let's maybe go into the calculator. We can do this algebraically, but I guess not knowing in advance, the fractions actually aren't going to work out. They're going to be okay, but we might be able to work this out a little quicker if we just use a calculator. So I'm going to go ahead and solve this using NSolve, I suppose. So here we are. Here is our calculator. Let's write out this equation. Menu, algebra, numerical solve, and what's our equation? It's -0.5 x plus 5 equals -2x plus 3, and what do we want to solve for? We want to solve for x. And it gives us a value, and we can write it out here. X is equal to -1.333333, so on. -1.33333, well, we have one whole, or one negative whole, and 1/3. So altogether we have -4/3. You can put this on a calculator as well if you want to convert it to a fraction that way. -1.33 should be fine as well. After that, we want to find the y value. Well, for that, we want to say y is equal to negative half, and let's substitute this x value, this negative 4, 3 plus 5, into our equation. And then, just like before, we can use nsolve once again, menu, algebra, numerical solve. In this case, we have negative 0.5. This is times negative 4 over 3 plus 5. Oh, that's it actually. So in this case, it's just, actually we don't need nsolve. Let's erase all this business and let's just write it out. Negative 0.5 times negative 4 over 3 plus 5. That's 5.666667. Okay. So 5.6666 is probably right. 5.66, and so on and so on and so on. We could write that as a fraction. 5 and 2/3 is a mixed number, or 17 over 3 if we wanted, I suppose. But that should be okay. So finally, our coordinate point, let's write it out here. Coordinate point would be, let's write it out using decimals, negative 1.33, keeping that 3 sig figs for the IB, and then 5.66. Okay. That'd be one way to do it. One last way, I mean, if you want a kind of like smorgasbord of opportunities, you can just graph it. So this might even be the most straightforward. Negative 0.5 x plus 5, that's our first equation. Menu, graph entry, function, and this is negative 2x plus 3. Alright, so we even have this point of intersection. We don't even need to change the window. Menu, analyze graph. Let's find the point of intersection. And there it is, negative 1.33 and then 5.67. That's our coordinate of our, I think that's actually going to be the most straightforward way. Okay. Okay, let's go on to the last one, C. Line L3 is parallel to L2 and passes through the point 2, 3. Find the equation of line L3, give your answer in the form of y equals mx plus c. Okay. Line L3 is parallel to L2. So what was L2? L2 was equal to, oh there it is, negative 2x plus 3. So let's go ahead and write that down. L2 is equal to negative 2x plus 3. And they're telling us something about L3. L3, what do they tell us? It has parallel to L2. So what could we do with that? We know that the slope, this is going to look a little funny, slope of ML2 is equal to ML3. Parallel lines are going to have the same slope. So the slope of L2 is negative 2. So M, the slope of L3, is going to be negative 2. Line L3 is parallel to L2 and passes through the point 2, 3. Okay. Equation of a line, y equals mx plus b. We know the slope is negative 2, so we have y is equal to negative 2x plus b, and they have a coordinate point for us, 2, 3 is x, this is y. We can substitute these values in, so if y is equal to 3, then we have negative 2 and x is equal to 2 plus b, and 3 equals, sorry, this x is 2, 4 plus b, b is equal to negative 1. Just bringing this over, of course, negative 4, 3 minus 4. In the end, we have y is equal to negative 2x minus 1, and that is our equation of a line. And I think we're done here. Give your form y equals mx plus c. Yeah, that's it.